We started 4.5 before the test, okay? Or 4.4, sorry. We started 4.4 before the test. That was that last thing that we learned. We have a couple more topics to continue with 4.4, and this second fundamental theorem of calculus is one of them. This is not a theorem that you're going to use to like prove things. It's more or less used to conveniently and easily and efficiently answer certain types of problems, okay? And so we're going to have kind of like a mini lesson on this, and then we're going to have another mini lesson. And then tomorrow you're going to get the class period to work on all this stuff. So what the second fundamental theorem of calculus says is that as long as we have a continuous function, if you derive an integral, I mean, think about you're deriving and integrating, what's that going to happen? What's going to happen here? They're going to cancel each other out, and you're just going to be left with the function. It's not going to be the integral or the derivative. It's just back to the normal function. Okay? Well, this is supposed to be a t. The reason these are t's here is to not distinguish between x up here, because what I'm going with this is, see, like on example 1, you can have, remember how we have numbers here normally? You can even have functions here. And it looks super complicated, but it's not. It's actually really easy. Don't get stressed out. Okay, but that's why, just to answer the question, that's why we have t down here and x up here. Okay, so we know that deriving and integrating basically cancel each other out. Now, if you have bounds, okay, especially bounds that are functions of x, okay, and you are taking the derivative, okay, so here we are taking the derivative of capital F, so capital F prime. In other words, we are deriving an integral. I'm saying this over and over again in different words so that you understand. When you're deriving an integral, okay, your function is going to stay the same, except you got to deal with your bounds. Okay, what does the first fundamental theorem of calculus say we have to do with those bounds? So last week. You plug them in, and which one do you plug in first? You plug the top one in first. So watch what I'm going to do here. Instead of explaining this, I'm just going to go straight into this example. Okay, this function is not changing, except that I'm going to take the top bound and plug it in for t. So instead of t, I'm going to have 2x. Instead of t squared, I'm going to have 2x squared, and then plus 1. Okay, so I plugged the top bound in for t. That's why the bounds are usually in terms of x, and the body here is in terms of t. And it has to be that way, but don't let that throw you. You're not really going to do a lot with it. I'm not done. Okay, remember when we derived inner and outer functions? What rule did we have? M&M's, what was the technical name of that rule? The chain rule. And what did we do with the chain rule? Once we did the thing, we had to multiply by the derivative of the inside. Okay, so we are going to take a derivative, but just of the upper bound. So what would the derivative of the upper bound be? 2. So I'm going to multiply that by 2. And we're halfway through the problem. Okay? What goes in between the two parts? What did we do last week? The minus. And I'm not even writing the bar here because I'm not even anti-deriving. I'm just I'm going straight into plugging in the bounds because I'm deriving and integrating. So here's what I'm going to have on the next one. I'm going to go ahead and put a parenthesis just in case I have several things. I want to make sure that I subtract everything that's next. And instead of t, I'm going to plug in the lower bound, which is x. So we're going to have x, parenthesis. Instead of t squared plus 1, I'm going to write x squared plus 1. And then you are going to multiply by the derivative of that lower bound, which is 1. That's it. That's how you do these problems. Now, of course, that can be simplified. Okay, we're not going to worry about that unless we have to simplify, in which case that would be like a multiple choice question. And you could simplify this. You have all the algebra skills to do it, but you don't have to. So let me repeat this one more time. When you are deriving an integral with bounds, particularly bounds that are functions of x, you were going to use this thing called the second fundamental theorem of calculus. Okay? Because what we could have done is we could have anti-derived, we could have plugged in the bounds, and then we could have derived what was left. Why do we want to do that? We can just do this, okay? It's like a shortcut. Okay, so even with trig, it doesn't get any more complicated. Okay, so don't let the cosine bother you. Okay, first of all, on these problems, once I've identified it as a derivative of integral, I like to circle the function so that I remember, hey, that's cosine of t. I'm not deriving or integrating. I'm just applying the bounds. So start with the upper bound. Okay, so f prime of x, that would be, instead of cosine t, it's going to be cosine of x cubed. And then immediately multiply by the derivative of x cubed. So what would I multiply by? 3x squared. Good. Minus parentheses. Okay. So based off of what we did in the last problem, what are we going to do now? Yeah, we're going to write cosine, and in place of t, I'm going to put in the pi over 2, and I'm going to go times, what's the derivative of pi over 2? y0. It is a number. And the derivative of any number when it's just by itself, that's 0. Okay, so here's my answer. Now, if we did need to simplify, what would happen to this whole second part? It would totally go away. So, in the future, when you recognize that one of your bounds is a number, you can just not write that part. And it's always going to be the lower bound, by the way. It's just going to work out that way. Okay? And so you didn't even have to write anything. You didn't have to write the minus or anything after it. Okay? That lower bound is a number. It doesn't affect this. Okay? All right. Why don't you try 3 on your own? Okay, peek over at a neighbor's paper, see if you got the same thing for 3. Okay, if someone wrote this, would this be right or wrong? Or incomplete, maybe? I could just be tricky today. So far what I've written, is that okay? Yes. Does anybody feel like there should be something after it? Like, what about the whole minus thing? The lower bound is a number. So what would I have ended up multiplying the second part by? 0. So it's totally fine for you just to have written this. Some of you might want to do the minus and go, oh, that's a 0. It's up to you. You don't have to simplify. Okay, 4, 5, and 6, that's going to be your classwork tomorrow. Okay, 6, that has some natural log in there. Don't let that freak you out. Okay, but it's a multiple choice, so you got to pick out the right one. So turn the page. And then here's our second mini lesson. And this is, we have already been doing AP style problems. In fact, excuse me, you have already been doing these problems since like you first knew about derivatives. Okay? Like back in late October, I think was the first time you saw a problem sort of like this. You had it for after parties. You had it for your semester exam. You have it on this 6 weeks after parties, okay? However, I haven't given you a true AP question yet because until we had our lessons last week, we really weren't ready for a certain part of this. So some of this is going to be review, some of this is going to be new. Okay? So what we're used to seeing is that they give us the graph of f prime and then ask us questions about f, right? And then recently I started showing you like, hey, here's a graph of f, it's the same as g prime, and here's some questions. But I haven't put this integral symbol in these problems yet. Okay, so here's the bad news is I'm adding on. The good news is this is an actual AP question. So once we are able to do all these things, there's no further place we're going to take this type of question. All right, something that's going to make these types of questions a lot easier is to make sure that we annotate and write out everything we know about the problem before we start really going through. I do just want to remind you guys that you have 15 minutes on average to answer each of these problems that are usually 4 parts. Sometimes they're only 3. And then you can get a maximum of 9 points per problem. And I'll show you how that's, how the points are allocated here. Okay? So, the first thing we're going to do is write out what we have. Okay, here's the graph of f. We have 3 line segments, a semicircle, and then they give us this formula, which I know is probably going to be important. Okay, so over here, I am going to write that formula out in shorthand to refer back to. G is the integral of f. And since this is the graph of f, how do you integrate a function based off of its graph? What are you doing? Taking the area trapped between the lines or curves and the x-axis. So I'm just going to, we'll practice that in a minute, but I want you just to go ahead and write area. So in a minute, when they ask us to do g of 0, we're going to have to be finding area of something. They're also going to ask us about g prime. Okay, so let's figure out, well, what is g prime? Well, take the derivative of both sides. We just talked about this. What happens when you derive an integral? They cancel each other out. Now, if you're like, hey, what about that whole second fundamental thing? Look at the formula here. If you plug in the top bound, you would have f of x times what? This is what we just did a few minutes ago. Times 1. So the times 1 doesn't really affect anything. And then what about the second part? Nothing, because the bottom bound is 0. So it's okay to just leave it just like this. So in a minute, when they ask us about g prime, they're really asking us about f. Now, what on this graph am I looking for? And I'm going to give you 3 options. Area, slope, or y values. For what is g prime, which is the same as f? If I looked on this graph, and I wanted to find f of 2, I would look at the actual point, which would be the y value. So if you were thinking slope, hold tight, because that's going to come up next. So watch what I'm going to do next. I'm going to take derivative of both sides again. So I'm going to get g double prime. What would I write on the right side? F prime. Since this is the graph of f, f prime relates to the slope of the graph. So the whole reason we wrote this, it's kind of like a legend on a map. It tells me as I go through these problems, if I need to do integral of f, I'm doing area. If I need to just do f, I'm doing y values or g prime or whatever. It's so easy to look at g prime and think slope. Well, g prime is slope of g, but I'm not given g, I'm given f. And it's like, have you ever been in the middle of one of these problems and you're like, wait, what am I doing again? Okay, that's what this legend is supposed to help you with. And I want you to start writing it on the problems that we're going to do. I don't think it was absolutely necessary before, but I think it is now. We have 2 functions. We have integrals, regulars, and derivatives, and even second derivatives. There's a lot of things going on, and we have to be really specific. Okay, so here's our legend. So we look at part A, and I'm going to kind of be scrolling up and down here. So for part A, the first thing we need to do is find g of 0. All right, now g of x is given by this formula. So when they're just asking about regular g, we need to use this formula. So the first thing we're going to do is just plug in 0 in for x. Yes?
So is the g of 0, is that just the function of the graph? Like,
so what g of 0 represents is the integral from -3 to 0 of f of x, which is the graph. So, and I know that's like a lot of words here. So let me show you like specifically on the graph what it means. It means if I start at -3 and I end at 0, what is the area of that piece? So g of 0, which is what they're asking for, is the same as the area under the curve of f of x, or f of t, or whatever you want to call it, between x equals -3 and x equals 0. So that's a trapezoid. We can do this in one go, or you can break it up and do it as a triangle and a rectangle. Okay, I'm going to just bite the bullet and do the trapezoid. It's really not that bad. When you're finding area of a trapezoid, you are averaging the two parallel sides. So what are those two parallel sides? 2 and 1. So I'm going to average 2 and 1. So add them up, divide by 2. That's how you do the height. You average the two heights, basically. And then the base times the base, the distance between. So what would that distance be? 3. And you're done. If you want to simplify this into 9/2 or 4.5, go for it. There's no need to on this problem to simplify. Because if you write this, you get a point. Don't write what I'm about to do, okay? If you wrote equals for, I don't know, that doesn't make sense. Hold on. If you were to say something like, oh, I think this is 5/2 or something, I don't know. They just say, oh, you earned a point, but now we're going to take it away. So you don't get any extra thing out of simplifying, so why simplify? That's kind of how I feel about it. All right, so you only got 1 point for that. All right, but that's because with a little practice, that's going to be a pretty easy part. Okay, so now we're going to do the second part of part A, which is finding g prime of 0. This is where the legend is mostly helpful. Okay, so if I go back up here and I say, oh, g prime, that's the same as f, which is the y value. Okay, so essentially what they're asking here when they say, what is g prime of 0? They're saying, what is f of 0? Or in other words, what is the y value when x equals 0? So what do you guys think? 1. 1. And that got you another point. So 2 points for part A. There's not a lot of work to be shown here. You just get a point if it's right or not if it's wrong. Okay? You didn't have to write f of 0. I just wrote it so that we could follow the train of thought here. Okay, so let's look at part B. So part B says find all the values of x. So we should have like x equals some number or some set of numbers or an interval of numbers or something. Find all values of x for which g attains a relative max. So we've got to think about what was our justification for g attaining a relative max. What was happening with g prime? And I'm going to draw a little graph of g. If this is the graph of g, what's happening to g prime? Right here. So g is changing from increasing to decreasing, and g prime is changing from positive to negative. There's also that chart thing that I gave you guys with the plus, minus, and the arrows. I'm not going to draw that right now. That's working for some people, and that's confusing some people. So you just got to decide if it's helping you, use it. If not, we got to figure something else out. So, recap. G attains a relative max when g prime changes from plus to minus. Well, I'm not given the graph of g prime exactly. It doesn't say g prime. So I got to say, okay, what is g prime the same as? It's the same as f, which are the y values. Okay? So let me finish the justification here. G prime, which is the same as f, is going to changes from positive to negative. Yeah. Okay, so G prime and F. Are we looking at where the area changes from positive to negative, the y values, or the slope? What does our legend tell us? The y values. So where do the y values change from positive to negative on this graph? At x equals 3. The y value is positive, 0, then negative. So right there at x equals 3, that's my answer. Okay, the way the points are doled out here is you get 1 point for the right answer. Okay, if you get the right answer, you get 1 point for a correct justification. If your answer's wrong, you do not get your justification point, even if you wrote what I wrote. The logic is you cannot justify a wrong answer. Okay, before we move on to C, so we just figured out that right there, G has a, which is not shown here, okay, this is the graph of F. G, though, has a relative max happening at x equals 3. What does G have going on over here at x equals -4? A relative min. Are there any other relative extrema? No, because right here we don't actually have a change. Okay, so that's going to help us with C, part C. Okay, so part C says find the absolute minimum. Okay, and we got to justify our answer. Anytime you see absolute, you've got to think, I need a candidacy chart. Okay, I need a T chart. And on this T chart, I need some X values. I don't have to pick every single one. And I need to plug them into G, and then the biggest answer would be my absolute max, and the smallest answer would be my absolute min. Okay, so do you guys remember what my possible candidates are? The endpoints, which would be -5 and 4. Like, this is not the graph of G, by the way. I'm just kind of doing this like this. So, see how the lowest possible point could be at an endpoint? It could also be at a relative min. Is there any way possible, you don't not have to write all this down. I just wanted to do this to show you. Is there any way the absolute min could occur at a relative max? Could that happen? Could the absolute lowest point on a graph be a relative max? That really logistically can't happen. Okay? So I want to show you something here, because if you recognize that, you're going to save yourself some work. Because after we put the interval numbers, okay, we also used critical numbers. And our critical numbers here would be -4 and 3. And you could even add in 1 there, because at 1 there wasn't a change in sign, but it was where G prime equals 0. These are our critical numbers. Okay, but if you can think this out logically, like, there's no way at a relative max we could have an absolute min, and same thing here, then that's going to save you some work. It's going to save you from doing 2 more calculations if you can get rid of things you know can't be the answer. If you don't recognize that, you're going to do a little bit more work, but you're still going to come up with the same answer. Okay, so here's what we need to do. We need to find G of -5. Okay, so we, in part A, let me scroll back up here. In part A, we found G of 0 by doing area. So that's what we're going to do again. So let's set up the formula, and I know I'm scrolling back and forth. Sorry if I'm making any of you seasick here. Whoops, that's not right. The formula said that the bottom is -3 and the top is whatever number is right there. And I'm going to erase all this because this was just to prove a point. Okay, so first of all, something's kind of weird here. What's weird about the order of these numbers? Yeah, usually you go left to right. This is going right to left. So how is that going to affect? It's going to put a negative. Okay, so let's go up here and let's find the area between -5 and -3. So we got this triangle and we got this triangle. See, I'm going from -5 to -3. Technically, I'm going -3 to -5 backwards. And I get a triangle that's above and a triangle that's below, and they have the same dimensions. What is the area of each of those triangles? 1. One of them's above, one of them's a below, so the integral is going to be a +1 and a -1. It doesn't even really matter the order here. What is that integral? What happens when you have a -1 and a +1 and you add them together? You get 0. Okay? So the negative part didn't matter as much. It could matter though on another one. Okay, so now we're going to do g of 4. Now keep in mind, I am looking for absolute min. So far, I'm looking for a number that's less than 0. Okay, keep that in mind as we set up the next problem. I probably should have written these bigger, sorry. So here the numbers are in the right order. So all that's good. Okay, so -3 stops at 4. And if you didn't quite get that written down, I'm going to scroll back down in just a second. So this time, I'm going to start at -3. Whoops, right up here in green. And then I'm going to go all the way to 4. Do y'all really want to calculate out this area exactly? Not me neither.
It's positive.
It's positive. How do you know that for sure? There's more on top than bottom, and see this little piece up here is going to cancel with this little triangle. So those are going to cancel, and then all the rest of it's above. So that's going to give me a positive result. Okay, positive something, I don't know, but it's not my answer. Okay, so I can stop there. All right, now we got to do g of -4. So I have the same situation that I did with -5. These things right here are going in the wrong order. Okay, we should be starting at -4 and then going to -3. But according just the way it's set up, it's backwards. So we got to do the negative. Okay, so what would that area be between -3 and -4? So in this case, we're just talking about just that triangle right there. We'd go 1/2 base times height. So 1/2 base times height. So -1. -1 is smaller than 0. So -1 is the smallest result. Do you guys see how if I had continued this with 3 and 1, the result would not be, the result would be positive, first of all. If I integrated from -3 to 3 or 1, like all of that would be positive. Okay, so you could continue this out if you wanted to, but you don't need to. The smallest number up here is the absolute min. Now, if this question was asking for the absolute max, what do you think we would have to do? We would have to actually find all 3 of these positive areas and figure it out, which means we'd have to do like semicircle stuff. It's not impossible, but it's not something they're typically going to ask you because it's very time consuming, okay? So you get 1 point for the answer, and then this right here is your justification. As long as your T-chart is easy to read and organized, that you're going to get 1 point. If your answer's wrong though, you don't get the justification point.
Why do we know it's not 3 or 1?
So if we integrate it, so the question is, how do we know it's not 3? So let's, down here, I'm going to try g of 3. So I would integrate from -3 to 3. If I go back up to the picture, I can see clearly, like if I do this in a different color, that this right here is all positive. And I'm looking for the absolute min, and I already have a -1 up there. So if I know an area is positive, that's how we knew at the end. How we knew at the beginning was because right there at 3, G had a relative max. You can't have the lowest point on a graph at a relative max. So whichever way you think about it.
Can you also say it changes from negative to positive, or do you have to include the t-type for absolute?
So if you say something about G prime changing from negative to positive, you have proved that you have a relative min, but you have not yet proved until you do the t-chart that you have an absolute min. And the key to the t-chart is that you have to test those endpoints. It could have happened at an endpoint. All right. All right, so we got one more part left. And I think D is actually much easier than C, so I want y'all to try that one on your own. Who thinks they got it? There were 3 answers, by the way. Mia, what'd you get? Okay, I'm going to agree with you on 2 of those.
X equals what?
So let's talk about why, yeah. So I think you probably were looking at the right point and just picked the wrong number. I don't know. So why is this right here not an answer up here? Yeah, it's decreasing, and then it decreases in a different way, but it doesn't change from increasing to decreasing, or vice versa. So that's really what your justification should have been. The easiest way to say this is has relative extrema. If you wrote changes from increasing to decreasing or decreasing to increasing, that's fine too. Okay, if you wrote because G double prime changes signs, you're not going to get the justification point because they don't give us G double prime. That's a true statement, but it's not how we knew. I would say if you're going to use the word direction, go ahead and be specific about increasing and decreasing. Yeah. I don't know if they would take that changes direction. I feel like they would some years, and then some year some grader's going to go, that's not good enough. The way these 2 points were allocated is, so like let's say you wrote -3, 0, 2. You would get 1 out of the 2 points. Okay? If you made 1 mistake. If you only had -3 written though, you wouldn't have gotten the 2 points at all. And if you don't get the answer right, you're not going to get the justification point. So we're looking at where this graph changes from increasing to decreasing. So right here, and right here. So what is that x value? 1. Yeah, they didn't tell you those coordinates, which made that a little tricky. Like they tell you the coordinates 0, 1, although you didn't really even need that. So, okay.